Hello all, this is Priyadarshini working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to look into the topic machine learning basics covered under deep learning. So now I'm going to tell you a story. So imagine two students who are practicing for or preparing for their forthcoming examination. So the student one, the first student, what he does is he memorizes the answer word by word. But whereas the second student, what he does is he, for all the answers, he understands the concepts clearly and deeply. Now, during the practice test, what happens is both the students perform very well. Their accuracy in the test is nearly 100%. But now think during their final examinations, what happens? When a new question is asked, what happened to their final examination? The student one fails, whereas the second student who understands the concepts very deeply, he succeeds. So, to understand why this happens, we are going to deep dive into the machine learning basics. So, this machine learning basics forms a deep foundation for the deep learning. So, we'll understand what are all the concepts that are necessary to have a deep learning syllabus, a very interesting one. Let's see, why do we need machine learning? So imagine we are training a self-autonomous car. So we have trained that self-autonomous car. Now we are taking it to the test track. So what happens? So when you see the track itself, you can understand the roads are very neat. The traffic cones are placed properly. The curves are very smooth, and there are no pedestrians, no sudden surprises in the test track. So now what a model does, or what a self-driven car does, the car drives very beautifully, is it not? It is nearly 100% accurate. It drove very neatly and beautifully. There is the model is 100% accurate. Now imagine when we take the same car to a city street, okay, that is to the real city street. So now here what our car or the model sees is there are pedestrians walking, there are many vehicles passing, it can see the traffic lights, the speed, the mileage thing can be seen, and there are lots of noises, and as well as you can see the uncertainty. Now what happens? Yes, you can imagine, right? The car crashes. Why does this happen? Because our self-autonomous model fails to generalize its knowledge to the real world. Why does this happen? Because our self-autonomous car did not learn to drive properly. Instead, it memorized the pattern of the test track. So, when it is taken to the unseen track, our model crashes. So, let's understand what is this generalization problem in a clearer manner. So we all know what is machine learning, is it not? Machine learning is nothing but it is the ability of a system to learn patterns and make decisions without any explicit programming. So we want our model to learn patterns and decide based on that. We don't want our model to just memorize and give the testing accuracy very 100% correct, and when it fails during the unseen data or during the real world problem happens, it fails. It performs too well inside the lab, but when it comes to the outside world, it fails. So we need not have this type of model. So in the previous example itself, we saw that when two students are preparing for the examination, the performance during the test, that is during the training, the error was too low, that is they scored even 100 percentage. They have performed very well on what they have seen. But when the final examination came, the performance of one student was high and wherein the other student he failed. So this gap is called the generalization gap. So we want our model not only be 100 percentage efficient during training, but also it should be a low test error when it sees an unseen data. So the model should have low training error as well as low test error. So this is called the generalization problem.